ROS nodes communicate using network technologies, and networks aren't always completely reliable. Packets get delayed or lost entirely. While this isn't usually a problem when all of our nodes are running on the same computer, it can definitely start showing up when your system gets distributed over multiple machines. Different nodes and topics will want different performance out of our communication stack. For some data, it's critical that you get every single packet, no matter how long it takes. For others, you might care less about dropped packets since it's more important that you get the latest data quickly. Quality of service settings let us express these performance priorities to the underlying communication system. There are several quality of service settings supported in ROS2. Each setting stores a value or policy that controls some aspect of the communication reliability. When you pick a specific value or policy for all of the settings, you end up with a quality of service profile. There are a handful of built-in profiles shipped with ROS that feature setting configurations appropriate for different use cases. Currently, there are 8 quality of service settings. The history setting controls how middleware should handle buffering messages waiting to be sent to the network or passed to a callback function. It can be set to one of 2 policies, keep last or keep all. Keep last will only buffer up to a configured max number of messages. Keep all will keep as many messages as the middleware resources can support. The depth setting is used to control the size of the history buffer when the keep last policy is used. The reliability setting controls whether the middleware will attempt to ensure that each message is delivered to the receiver. There are 2 policies to choose from. Best effort may lose messages if the network can't deliver them. Reliable will guarantee that messages are delivered by retrying to deliver any messages that failed to make it across the network. The durability setting controls whether new subscribers get the most recent message when they subscribe, or if they have to wait for the next published message. The transient local policy means that the publisher will hold on to the most recent message and send it to all new subscribers. The volatile policy means that this doesn't happen, so the new subscriber won't get anything until the next message is published. The deadline setting specifies the maximum amount of time between messages on a topic under normal, healthy operation. This is one way for our nodes to detect if a topic has become non-responsive. The lifespan setting describes how long a message is considered valid after it's published. If a subscriber receives a message older than its lifespan, the message is considered expired and is silently ignored. The liveliness setting controls whether a node's topics are tracked together or individually for activity or aliveness. The automatic policy says that all of a node's topics are considered alive if any of the node's topics has published a message in the last least duration. The manual by topic policy tracks liveliness of each of the node's topics independently. Each topic in the node has to publish a message for that topic to be considered alive under the manual policy. The least duration setting controls how long a topic publisher stays alive after each published message. This works with the liveliness setting to track topic activity. And that's all the settings currently supported in ROS2. There are just enough to make it kind of a pain to keep track of. Luckily, we're not usually so concerned with individual setting values. More often, we work at the profile level. Each profile is a complete set of quality of service policies. There are a handful of profiles defined in ROS, and you can make your own with the RCL-CPP API. 2 that show up frequently are system defaults and sensor data. The system defaults policy uses all of the default values as defined by the middleware implementation we're currently using. As a result, the exact settings used might change between different environments, but they tend to be a reasonable set of policies for general purpose topics. The sensor data policy focuses on getting the latest data quickly, even if that means losing some messages along the way. This policy sets the reliability setting to best effort and maintains a smaller history buffer size. You've already seen how we use these quality of service profiles in our C++ ROS code. When creating different kinds of ROS connections, we've used the system defaults profile by passing in RCL-CPP system defaults QoS. This is a class provided by the C++ client library that sets all of the settings needed for the system defaults profile. This class inherits from RCL-CPP QoS, which you can use to create your own profile of custom settings when you need to. You may have noticed that some of the quality of service settings kind of need to be agreed upon by both the publisher and subscriber for a topic. Some combinations of settings are compatible and others are not. The ROS documentation gives us tables laying out the compatibility rules for each setting. In order for a publisher and subscriber to actually connect, all of their quality of service settings must be compatible. Any one incompatible setting is enough to prevent the connection entirely. The last thing to cover in this video is quality of service events. We can pass additional callbacks when creating publishers and subscribers that will be called when certain quality of service events occur. These events include things like when a publisher loses liveliness or a message deadline is missed. While we don't always need to register these events in our code, the ability to do this is an important part of making real-time, safe systems that behave predictably when network problems interfere with message passing. And that's all for today. Even if you ignore these quality of service settings in most of your nodes, it's important to know that the options exist when you hit a situation where it matters. And there will be times where you need to make sure you set up compatible quality of service settings in certain tools like RViz.